everybody. We are discussing simple harmonic motion, the continuation of the same chapter. In fact, simple harmonic motion, when we have taken up earlier, we have discussed the basic equations which represent simple harmonic motion of a body, maximum velocity, maximum acceleration, and when to take a cost function while writing the equation for a particle in SHM, when to write a cost functional wave equation, and what are the important features of those equations, and so on, we have already taken up. Now let us take few examples which will cover simple harmonic motion in brief. The general concept is simple pendulum, a loaded spring. These are the commonly asked model examples. When we just take up simple pendulum concept, let me remind you few formulae first before entering to the applications part of it. Simple pendulum, whenever we take, the time period t is equal to 2 pi under root L by G. That is the formula that is to be remembered first. And what about its frequency? It is 1 by 2 pi under root G by L. This is the equation to be taken up. And of course, from the same, what is its angular frequency? It is under root G by L as such. In addition to that, if at all acceleration due to gravity at a particular place is to be calculated using simple pendulum, we people used to take up 4 pi square into L by T square. That is the formula what we people used to prefer taking. So these are the four major equations one should remember as far as simple pendulum that is concerned. And of course, while taking up each and every equation, depending on the case, some of the quantities we can take them constant. For example, at a particular place when you people are dealing with, acceleration due to gravity can be taken constant, and you can write T is proportional to root L. Likewise, N is proportional to 1 by root L. Likewise, omega is proportional to 1 by root L. That way, of course, we people is to take depending on the case, whatever it is. These are the major equations one should remember as far as simple pendulum that is concerned. Now, when we talk about the second one, that is a loaded spring or a spiral spring, what we people is to take up. While taking spiral spring, the spring constant K is equal to mg by x is a very commonly asked formula. Based on this, of course, we people are going to have several applications. And coming to the next one, what is the time period of a loaded spring which is oscillating vertically up and down? That of course 2 pi under root m by k we people is to write. What is this m over here? We all know that is the mass that is attached to the end of the spiral spring, and k is called either force constant or spring constant for that matter. Same equation can even be rewritten 2 pi under root x by g also. X being the elongation and g being the acceleration due to gravity at that place where it is now vibrating vertically in the vertical plane up and down, that is the point. Exactly like that, what is its linear frequency? It's either 1 by 2 pi under root k by m, or you can even write the same 1 by 2 pi under root g by x as such. So these equations you people have to remember, one for time period and one for frequency of a loaded spring as such. Coming to the next one, what is going to be its angular frequency? That of course you can write either k by m under root, or you can even write g by x under root. So these are the major equations one should remember while taking up any loaded spring or oscillations of a loaded spring in the vertical plane like that is concerned. So mainly these aspects, if you are thorough with, certainly you can work out almost every model question whatever that is asked based on this particular chapter as such. Let us now take, by considering all these basics into account, let us take few applications now. Let us see the problems based on these particular formulae as such. Let us see the very first number. See that one. The mass and diameter of a planet are 2 times those of Earth. If a second's pendulum is taken to it, the time period of the pendulum will be how much? Okay, before taking up the problem, I just want to mention the importance of second's pendulum in this particular chapter. Second's pendulum is that pendulum of which time period is exactly 2 seconds. And its length, of course, on Earth, we people used to take this one as exactly 1 meter. Almost nearly one should say 1 meter is the length commonly what we people used to take up. Or of course 100 centimeter. And what will be its length on the moon? Suppose if they ask, it's 1 by 6 meter. This is what you have to remember. In addition to that, how many times a second's pendulum is going to oscillate in a day? Of course, we are knowing very well 86,400 seconds we have in a day. Then automatically number of oscillations will be by 2. What for by 2 also you can better understand, for every 2 seconds it oscillates once. So how many number of times it oscillates in a day means 43,200 times per day that second's pendulum is going to oscillate. So second's pendulum, whenever they talk about in any of the problems, these are the important features one should remember. Now let us take the problem here given. If the mass and diameter of a planet are 2 times those of Earth, then what will be the time period of second's pendulum on that particular planet? We in fact know T is equal to 2 pi under root L by G. Here 2 pi being a constant and length of second's pendulum also is constant, it is not being varied in the problem. Thereby T is inversely proportional to root G. That is the equation one should consider. Now you can write T on Earth divided by T on planet. This of course you can write this way. It has G on the planet divided by G on Earth under root. Directly you can write it like this. This is the concept. But what exactly is the value of G on planet? In fact, G value you all know, Gm by r square in brief. But according to the given problem, mass is doubled and radius also is being doubled. Then what happens? This 4, of course 2 by 4 means it becomes half. So half of Gm by r square you will get. But what is Gm by r square officially? It is the value of G on Earth. Therefore, G on Earth by 2 will be the G value on the planet. Then what can I write in place of G on the planet by G on Earth? Is it not simply 1 by 2 please? You can understand G on planet by G on Earth is equal to 1 by 2. Since it is under the root 1 by root 2, I can directly write. Now what is the value of second's pendulum's time period on the Earth? It is in fact 2. We know that point very well. Now if you take up this matter, T on the planet is how much? That is the question. It is now going to be 2 times root 2 over here. So what is going to be the key over here? If you look at the 4th option is going to be correct key over here. 2 root 2 seconds. If you look at 2 root 2 seconds is the time period of second's pendulum on that particular planet of which the mass is double that of the Earth and even diameter also is double that of the Earth. That is question number 1. Let us now check the second problem as such. The bob of a simple pendulum of mass 100 gram is oscillating with a time period of 1.42 seconds. If the bob is replaced by another bob of mass 150 gram but of same radius, the new time period of oscillation will be how much? In fact, this is the equation for time period of a pendulum. T is equal to 2 pi root L by G. Careful observation of this equation indicates that this time period is independent of mass. That means what you should understand here, it is independent of the mass. Independent of mass means what you can understand, it does not depend on mass, fine. But the condition is L should not be varied. Suppose if that fellow says a bigger bob or a smaller bob than the earlier one, then automatically length also will be varied. When length changes, time period also is going to be varied. But in this problem, it is very clearly mentioned that if the bob is replaced by another bob of mass 150 gram but of same radius, when radius is same, length in both the cases will not be affected. When L is not affected, T also will not be affected there. So what will be the value of time period? Again, it is again same as before, 1.42 seconds only. There will not be any change in time period. So what is the correct option? If you look at, the third option is going to be the correct one. So what one should remember is, when length is not changed, or you can otherwise say when radius of the bob is not changed, it is time period is independent of mass of the bob as such. That is the concept we have to take. Now look at the very next problem there, please. Problem number 3. A seconds pendulum is shifted from a place where G is equal to 9.8 meter per second square to another place where G is 9.78 meter per second square. The change in its length so that its time period of oscillation does not change would be that. How much it increases or how much it decreases, that is the question that is being asked. But one thing should be remembered first of all, this question has been asked in one of the EAMCET examinations earlier. In fact, we know T is equal to 2 pi root L by G when I write. You can even write the same thing this way, G is equal to 4 pi square into L by T square is the formula. But naturally, we can write from this one what will be the length of the pendulum as such. Length is going to be gt square by 4 pi square. This is the equation from this above equation. Now the concept is, for a seconds pendulum, time period is 2 seconds. So 2 square will be 4 and this 4 and that t square they get cancelled. Now what is left over? G by pi square is now going to be the value of length of that seconds pendulum at a particular place as such. Now let us consider, at the first place I can write this one as G1 by pi square. At the second place, L2 can be written as G2 by pi square as such. Now the question is, what should be the change in length for that seconds pendulum to have the same time period as that of 2 seconds as earlier? That is the question that is asked. So delta L now is going to be L1 minus L2. So what will be the formula? G1 minus G2 by pi square is the formula. What is G1 given? 9.8. G2 given 9.78. So 9.8 minus 9.78 by pi square. You will now be getting delta L value is 0.02 by pi square meter as such. But very cleverly he is giving all the options in centimeter, please, not in meter. So naturally, if you want to convert this one into centimeter, multiply this one by 100, please. So won't you be getting 2 by pi square centimeter over here? But one thing should be understood here, L and G are directly proportional to each other. Therefore, since G value is decreasing from first place to second place, even this length also should be decreased. So see the options now. It should be decreased by 2 by pi square centimeter. That must be the very first option what has been mentioned over there. That is the correct option for this question number 3. Now let us check the next number, please. Question number 4. A seconds pendulum is suspended from the roof of a lift. If the lift is moving up with uniform acceleration of 9.8 meter per second square, then its time period would be how much? This type of a question, in fact, is a linked up model. That link up is with the dynamics part of it, that too a lift problem as such. We can understand well, T is inversely proportional to, or T is equal to 2 pi root L by G when I write. I now can write T is inversely proportional to root G. That is the equation actually. Now I can write from this one, T1 by T2 is equal to under root G2 by G1. What is G2 in this case? Since the body is moving up, the lift is going up with an acceleration A, and acceleration due to gravity that is acting vertically downward in the downward direction, then what will now be the relative acceleration? Relative acceleration now becomes g plus a as such. So what should we write in place of g2 now? It is g plus a by g. But what is the value of g? We all know 9.8. What is the value of a that also has been given? 9.8. So you can write 9.8 plus 9.8 by 9.8 under root. That is actually the concept. T1 by T2. That is the case. Now you can certainly understand, is it not simply root 2 please? Because 2 times 9.8 by 9.8, it now becomes root 2. What is the time period is the question. So T2 will now be T1 by root 2. Already we know T1 is 2 seconds for a second pendulum. So 2 by root 2, how much will now be the value? Root 2 seconds as such. Search for that option now please. It is the second option that's going to be correct over here. So root 2 seconds is going to be the time. Suppose if that fellow says, by any chance, if the body or the lift is going vertically downwards with uniform acceleration. So that time, instead of plus sign here, we people used to put minus sign. That is the only change you people have to remember as far as this particular model that is concerned. Now look at the next question, that is question number 5. If you just read that, the length of second pendulum is 1 meter. Its length at a point of intersection of LT graph and LT square graph plotted on the same graph paper is. One of the excellent models, once again a simple question, but one should have a perfect observation to know what exactly the answer for this. In fact, we know when we plot L versus T square graph for a particular pendulum at a place, we will be getting a straight line passing through the origin. Exactly in the same manner, L versus T, when I just plot a graph, I be getting a curve like this. We people can understand these two. Now the concept is, he is asking us to plot both the graphs, T square versus T square, LT square, LT graphs. Both suppose are drawn on the same graph paper. Then definitely you will be finding the curve is going there and straight line like this you will be having. What is this point? This is called the point of intersection. What is his question now? What will be the corresponding length at this point of intersection? That is the question. What is this corresponding length is the question now. One thing should be understood here. Look at carefully. At this point, L by T and L by T square values are supposed to be equal. That means what will be the corresponding time over here please? 1 second. How do you know it is 1 second? For 1 second, both T as well as T square are going to be same. If T is 1 second, T square also will be 1 second square. That value 1 will be coinciding. So T corresponding to this point is going to be 1 second. Then what will be the length here? That is a question. In fact, T is equal to 2 pi root L by G. We directly can write this way. L1 by L2 is equal to T1 square by T2 square. That is the formula I can take. L1 is going to be 1 meter for a second pendulum. And of course, L2 is how much is my question? And T1 will now be 4. And what will be T2 here according to this calculation? T2 square will now be 1. Now you can directly write from this one, L2 will be 1 by 4 meter. What is this value of 1 by 4 meter please? Is it not 25 centimeter as such? So what is the corresponding option now to be taken up? The very first option you see, 25 centimeter, it is very clearly mentioned there. That means when LT and LT square graphs both are plotted on the same graph paper, corresponding to the point of intersection, time period value will be 1 second and length value will be exactly 1/4 a meter or 25 centimeter as such. That is the corresponding answer for the question number 5. Let us check the next number please. That is question number 6. When a body is suspended to a spring, its length is increased by 0.2 meter. Then the body is further pulled down by 5 centimeter and released. Its time period of oscillation will be how much? In fact, we all know well for a pendulum also, the oscillating time is independent of amplitude. Amplitude need not be taken into consideration while considering the time period over there. Exactly, even in this case also, time period is going to be 2 pi root x by g. That is the formula. X is the value of elongation or increased length, and g anyhow is acceleration due to gravity. So then the body is further pulled by 5 centimeters is just to confuse you people, nothing else. That 5 centimeter has nothing to do with our calculation. How much is the elongation? That is 0.2. So you can write directly 2 pi under root 0.2 by 9.8, the value of g that is there. Of course, point you can cut it off. 2 cancels 49 times. So it is 1 by root 49. Is it not 1 by 7 please? So 2 pi by 7 seconds. That is going to be the corresponding time period of oscillation of the body. So what is the corresponding answer for that one now? The second option is going to be the correct option. 2 pi by 7 seconds is the correct value over there for this question number 6. Right? Let us check the next number, that is question number 7. A spiral spring has a length L and force constant K. It is cut into two parts of lengths L1 and L2 such that L1 is equal to NL2, where N is an integer. The force constant of the part of length L1 is how much? One should understand first of all 2 points here. When a spiral spring is taken up this way, having a force constant or spring constant value as K, when it is cut into n equal parts, for example, if we take like this, then the value of K of each part will be n times the value of K of the original one. Suppose if it is made 2 parts, 2K, 3 parts, 3K, n parts, nk. This is when they are of equal parts. But in this particular problem, that is cut into 2 pieces, no doubt absolutely in that. But the lengths are not equal. L1 and L2 are the lengths he has given. And what is the relationship between these two? L1 is given NL2. That is the relation mentioned. So in such cases, that means the case in which the lengths are not uniform, not equal like, then you should understand that K into L of each piece should be constant here. K into L is constant means for the first piece I should write K1 L1. For the second part I should write K2 L2. For the original piece I can write K into L1 plus L2. Why? Because the total length you will get after adding these two lengths individually. So this is actually the concept. Now what is it we just want here? What is the value of K1 I want? He is asking you force constant of the part of length L1. This much is the length L1. So K1 is the corresponding force constant which is to be calculated. Come on, equate these two. K times L1 plus L2 by L1. But already we know what is the value of L1. It is NL2. Write that value. NL2 plus L2 whole divided by again NL2 as such. Come on, take this L2 common there. So what will you get? K into N plus 1 into L2 divided by NL2 as such. L2 getting cancelled. What is now left over? K into N plus 1 by N. This is the value of K1 which is of the first part over here. Now look at that option, tallied with which option it is there, like K into 1 plus N by N. The second option is tallying over there. So second option is correct option for the question number 7 as such. So that is the concept. Right, wonderful model it is, a very important model also for you. Now check the next question, that is problem number 8. A simple pendulum of length L is connected to the ceiling of a vehicle that is moving down along a smooth inclined plane having inclination 4 in 5. The time period of oscillation of the pendulum is how much? In fact, we know this language. What do you mean by 4 in 5? 4 in 5 is nothing other than Sin theta value over here is 4 by 5. That means if I imagine a right angle triangle taking this as theta, opposite side value must be 4 and hypotenuse value must be 5. Then automatically adjacent value must be 3 over here, you can identify by Pythagoras theorem. Now in this particular case, what is the thing he is asking? What is the time period? When the body is sliding down the inclined plane, 2 pi under root L by g cos theta. That is the corresponding formula one should remember. When it's sliding down an inclined plane having angle of inclination theta, then L by g cos theta under root into 2 pi one should take for the time period as such. Now you can write 2 pi as it is. Root of L by g also you take as it is. What is this cos theta now? According to this triangle, cos theta is equal to adjacent by hypotenuse 3 by 5. So automatically this becomes 5 by 3 as such. Now you can directly understand this value. It is 2 pi under root 5L by 3G. That will be the time period over here. Now if you look at the carefully over there, the third option that is tallied with this equation. So what is the corresponding formula when a simple pendulum oscillating from the roof of a car is sliding down an inclined plane like 2 pi root L by g cos theta? That is the corresponding formula, and this one is the corresponding answer for that, which is tallied with option number 3 there. That is question number 8. Now let us check the next number please. That is question number 9. A simple pendulum with a brass bob has a time period capital T. The bob is now immersed in a non-viscous liquid and made oscillated. If the density of the liquid is 1/8 of the density of brass, the time period of the pendulum now will be how much? One should once again take the same old equation for time period. T is equal to, no doubt, 2 pi under root L by g itself. Absolutely no change in that. And of course, simple pendulum of brass time period is given T. Then what is the question there? Time period of the pendulum now. So T1 by T2 now can be rewritten as G2 by G1 under root. That is the concept. A different model question here. What is this G2 now? It is G1 into 1 minus density of the liquid by density of the solid. This in fact is the equation what we people have learnt in the chapter called viscosity and other aspects like. So when you talk about this one, what is the density of the liquid that is given? 1/8. So automatically you can write G1 into 1 minus 1 by 8, because G is rho solid that gets cancelled. 1 by 8 means, is it not 7 by 8 times G please? Now look at what is the equation we have. Then G2 by G1 can now be rewritten directly as 7 by 8 over here. So write that value over here, 7 by 8 under root. But in fact, I don't want this equation. I want the value of T2. So what will be T2 now here? It is T1 root 8 by 7. In fact, we know very well what is going to be the corresponding value there. 8 by 7 into T1, initial time that is given as a T in the problem, therefore T root 8 by 7 will now be the corresponding answer. Look at that one which it is tallying over there. The very first option is going to be tallied. Root of 8 by 7 of T, because T1 is the time period of seconds pendulum, yes, simple pendulum that has been given T in the problem as such. So first option is the correct option for us. Now look at the next number, problem number 10. A force of 6.4 Newton stretches a vertical spring by 0.1 meter. The mass that must be suspended from the spring so that it oscillates with a period of pi by 4 seconds. It is the concept of a loaded and oscillating spring. That is the case what one has to take up. Now let us take what is it given. Force is given 6.4 Newton. Very clearly it is mentioned there. And what is the value of vertical displacement that has been given here? It is given 0.1 meter as such. Now taking these two, can't you just calculate what is the value of force constant of that spring first of all, please? It is mg by k, that is x. K is equal to mg by kx directly. What is going to be mg here? 6.4 by 0.1. Point getting cancelled, 64 Newton per meter. That is the value of force constant of that spring what has been given over here in the problem. Fine. Now what is next concept here? When it is to oscillate with a time period of pi by 4 seconds, what amount of mass that is to be attached to the spring? That is the question. So T can be written as 2 pi under root m by k. Let us now write this m as a capital letter M, because this is the mass what is being asked in the problem as such. Now T must be how much? It is given pi by 4. Fine. Is equal to 2 pi under root m by k. That value already we have calculated as 64. Then what will you get? 2 pi by root 64 is 8 into root m. This is the concept. Now pi gets cancelled, 2 goes here 4 times, 4 and 4 also they get cancelled. What is now left over? Root m towards my right is equal to 1 towards my left. Then what will be the value of m, please? Squaring up 1, it now becomes 1 kg. So what amount of mass that is to be attached to that one, so that the time period becomes pi by 4 seconds? That is the concept that is asked. So automatically the correct option over here will now be the second option there, please. That is the concept. Okay, now let us check the next number, problem number 11 as such. A simple pendulum of length 81 centimeter takes 3 minutes to execute 100 oscillations. Fine. The time that a pendulum of length 121 centimeter takes to make the same number of oscillations. That same word is to be taken up very carefully there, is to be read. Otherwise we think something else over there. So what is the concept here? 81 centimeters is the length. 3 minutes it is taking to complete 100 oscillations. So n is equal to 1 by 2 pi root g by L. That is the formula officially. Now you can write directly n1 by n2 is equal to root of L2 by L1. That is the concept. But what is n1 here? Number of oscillations made by the pendulum in 1 second. But of course you can understand here 100 oscillations it is making in 3 minutes. So n1 should be written as 100 by 3 as such. That means I am taking the frequency per minute here, because all the 4 options are also given in minutes only. No need for us to convert them into seconds anymore. Divided by what should be n2 now? Again 100 oscillations only. But how much time it is taking, we in fact do not know. That is now to be calculated separately. So this is equivalent to n1 is the first one. What is its length that is given? 81. What is that of the second one given over here? 121. Now of course you can write this one. 121 centimeter is going to be the value of length. Now 100 gets cancelled. T by 3 you will be getting here. What is this one? 11 by, this will be 9. Now directly you take T is equal to 33 by 9 seconds, whatever the value you will be getting here as a 3 point something like 6, like around 3.7, 3.66 minutes will now be the value what you people are going to get as the time period there. That means the second option that's going to be true for this particular question. Remember, same number of oscillations the body is making, but in a different period of time. That is what has been asked here. That is what we have calculated here. Now let us check the very next number, please. Problem number 12. The time period of a simple pendulum oscillating in a lift is 2 by root 3 seconds. When the lift moves up with some acceleration, its time period increases to 2 seconds when the lift moves down with the same acceleration. The time period of the pendulum in stationary lift is how much? Stationary lift means what? The body should not have any sort of an acceleration. Only acceleration due to gravity that is supposed to act on that particular pendulum as such. Now suppose if you look at the first half of the question there, 2 by root 3 seconds when the lift moves up with some acceleration. Up means you can understand if acceleration is A and acceleration due to gravity acting downward is G, then relative acceleration now becomes G plus A, I have already told you. Then what should I write now? T1, how much is the time period? 2 by root 3 is equal to 2 pi under root L by G plus A. That is the first equation for us. And what is going to be the second equation? With the same acceleration, when it is going downward, what will be the relative acceleration? I have already briefed you earlier. It becomes G minus A. Then what will be the time period given? It is 2 seconds that is given, 2 pi under root L by G minus A as such. That is the second equation. What is the question that is asked? T is equal to 2 pi root L by G. This value is how much? That is the question what is asked. Come on, take these two cases first of all. What can you write? Just take the ratio please. What will you get here? 2 by root 3 by 2. It is 1 by root 3 is equal to root of G minus A by G plus A. You can directly take this by this, 2 getting cancelled, 1 by root 3 is equal to root G minus A by root of G plus A. Now I can write just by squaring it up, 1 by 3 is equal to G minus A by G plus A. Then what will be the value if you cross multiply it? G plus A is equal to 3G minus 3A. In other words, I can write 4A is equal to 2G over here. Now A will be how much? G by 2. That is the relation. When A is G by 2, take the first equation and third equation. Just take the ratio right now. Taking the ratio means what? This by this you write. That is 2 by root 3 into T. This by this I am writing is equal to what? Root G by this value G plus A as such. What is this value of A here? It is G by 2. G plus G by 2 will now be 3G by 2. That in fact you will be getting root 2 by 3 under root is equal to 2 by root 3 into T. Now you can directly cancel this root 3 over here. Then what is left over? T root 2 is equal to 2. Then what will be the value of T? It is 2 by root 2. What will be this 2 by root 2 value? It is definitely going to be root 2 only. That means what is the correct option there please? Third option is going to be the correct one here. So 2 by root 2 which now becomes root 2 seconds. One of the excellent model questions is this one, right? Now check the next problem, that is problem number 13, which of course is purely a mathematical oriented question please. Look at this one carefully. A simple pendulum is oscillating with a maximum angular displacement of theta radian. If theta is very small, the ratio of maximum tension to the minimum tension in the string during an oscillation. One oscillation when you take of a simple pendulum, when it is at extreme position, tension will be minimum. When it is crossing the mean position of rest, tension will be maximum. This of course we have read even in the chapter called rotatory motion as such. Now when you take these two values, what will be the formula for maximum tension first of all? It is nothing other than mg plus mv square by r. That is actually the formula. R in this particular case is taken as length of that pendulum. And what will be this v square here? V square is equal to 2gl into 1 minus cos theta. That is actually the formula according to the concepts of kinematics. Now if you look at this value, substituting that one here, T maximum, now you will be getting it like this as mg plus this m by l, right, into 2gl into 1 minus cos theta. That is the formula officially. L gets cancelled. Fine. Now you can write mg plus 2mg here into 1 minus cos theta, you write 2 sin square theta by 2. Now when you write this way, sin theta, you all know when theta is very small, sin theta can be written theta. Limit theta tends to 0. Sin theta by theta is equal to 1 is the equation which we know. So if you write this value, what happens to this sin square theta by 2? It now becomes theta by 2 into theta by 2, which now becomes theta square by 4. Then what is now left over, you see? Maximum tension over here will now be mg plus this 2mg as it is into 2. Now directly you can write this one 4mg into theta square by 4. Now okay, 4 getting cancelled. What will be left over? mg into 1 plus theta square. This is the formula for maximum value of tension. But what is the corresponding value he is asking you? What is the value of minimum tension also we just want? What is the minimum tension here? mg cos theta. How to write this one? mg into 1 minus sin square theta by 2. Directly we can write. Now if you write like this, what will this value be again? Theta by 2 into theta by 2, theta square by 4. I can now write mg into 1 minus 2 sin square theta by 2. You will be getting this value. Theta square by 4 means theta by 2, theta square by 2 you will be getting here. That is the concept. Now if you look at this one, T maximum by T minimum, mg gets cancelled. Now what is left over, you see over there? 1 plus theta square is left here. 1 minus theta square by 2 is left towards your right. That means 1 plus theta square is to 1 minus theta square by 2. This must be the corresponding option. So which option that is tallied there, you look at carefully. 1 plus theta square is to 1 minus theta square by 2. This particular option is the second option for this question number 13. So this is purely a mathematical model based on simple harmonic motion as such. Now check the next problem, that is problem number 14. Two simple pendula are drawn to same side from their mean positions and are released simultaneously. Their time periods are 2 seconds and 3 seconds. The phase difference between the pendula when the longer pendulum completes one oscillation is how much? That is the concept what we just want. Now in fact for the first pendulum, y1 can be written as a sine 2 pi by capital T. What is the time period of the first one? 2 into small t. This is a sine omega t equation. What will be the equation for the second one, please? A sine 2 pi by 3 into t as such. Now what is going to be the phase difference is the question. Phase difference means it is delta phi we people is to write. So 2 pi by 2 minus 2 pi by 3 whole multiplied by t. Now 6 of course over here I can take up. This one of course 1 by 6 into 2 pi into the value of t. Fine. The point is that 2 getting cancelled, pi t by 3 I will get. Good. But what is the question? Carefully you look at. The phase difference between the pendula when the longer pendulum completes one oscillation. How much time that the longer pendulum is taking, please? 3 seconds. So in place of this t, you should now take the value of its time period. 3 gets cancelled. What is now left over? Pi. What is this pi now? Pi radian will now be the corresponding angular displacement, or in this particular case it is called phase difference between these two pendula. So pi radian, which option that is going to be tallied? Fourth option is going to be the correct option for us in the question number 14 as such. Now check the next problem, that is problem number 15. Two simple pendula of lengths 100 centimeter and 144 centimeter start oscillation together at time t is equal to 0. The minimum number of oscillations made by the shorter one after which they swing together again is going to be how much? That is the concept. One should remember a small concept by theory here, please. When the longer pendulum remember this point carefully. When the longer one makes n oscillations by any chance, the shorter one that now makes n plus 1 oscillations. That in the sense what? Always there will be a difference of either one oscillation between them or a fractional oscillation between them. The difference will not be more than 1 is the concept generally. So if you write n is equal to 1 by 2 pi under root g by L, then I can write n1 by n2 is equal to root L2 by L1, the formula. If I take n1 is the longer one, how many oscillations it makes? N oscillations I said. Now n2 is of shorter one, n plus 1 number of oscillations it makes I said. Root of shorter length, what is that one given over here? 100. What is the length of the longer pendulum? 144. Root 100 being 10, root 144 being 12, it is now 5 by 6 as such. Cross multiply this. 6n is equal to 5n plus 5. Now n will be 5 here. Look at carefully. What is this n I said? Longer pendulum makes 5 oscillations before they come into the same phase. But the question is asked the other way. How many number of oscillations the shorter one that makes? Shorter one makes how many oscillations? Plus 1. So it makes now 5 plus 1, 6 number of oscillations before they once again enter into the same phase as such. So what is the correct option over here now? The fourth option is going to be the correct option for us. That is question number 15. Now look at the next number, that is question number 16. Two springs of force constants K1 and K2 are connected to a mass m as shown. The frequency of oscillation of the mass is F. If both K1 and K2 are made 4 times their original values, the frequency of oscillation becomes how much? That is the question. In fact, if you look at carefully from the figure, both the springs when are connected to the body like this, one should understand that both the springs are connected in parallel. Then this value is K1, this value is K2, means the effective value over here is now going to be K1 plus K2. That is the concept one has to remember. Then what will be the frequency here? Frequency formula is 1 by 2 pi under root K by X, that K by M, that is the formula what we people used to take up. Generally this is the one. Now in this particular case, what is F given? That is the corresponding frequency 1 by 2 pi root K by M. This is actually the concept. What is this K now? It is simply K1 plus K2. That is what has been given. But now the question is K1 and K2 both are made 4 times. Then what will be F dash please? 1 by 2 pi root 4K1 plus 4K2. That can now be taken 4 times K1 plus K2 by M. Is it not simply 2 times F please? That means if you take 1 by 2 pi root K1 K2, K1 plus K2 by M, this root 4 comes out now. So what will be the corresponding option over there? You look at once again. The correct option will be 2 times the frequency of the original one. Means what? Third option is the right option for us. That for the question number 16, third option is the correct option there. But remember, whenever the springs are connected to the mass this way, they are said to be connected in parallel. Remember that point. Now look at the next problem, problem number 17 please. Two blocks of masses m1 and m2 are suspended from a light spring of force constant K. When the system is in equilibrium, block of mass m1 is gently removed. The maximum speed attained by the block of mass m2 is how much? One thing you should understand first of all, what is the maximum velocity officially? Is it not A omega please? That is a general formula, but for a spring, omega can be written as root of K by M. So this is the formula ultimately one has to remember. Now when m1 is removed, what will be the decreasement in the displacement or the amplitude of the body? What will be the value of x, please? It is mg is equal to kx we people is to take. So automatically it is mg by k we people is to write. What is this m now in this case? This x to be written as a, m is to be written as m1g by k. Why we people have to take m1? Because after removing m1 only, there is a slight variation in the elongation of the body. That is the concept. And what is going to be the value of this omega now? Omega now becomes root of k by m. Which m to be taken? Whatever the mass that is readily existing now. When m1 is removed, m2 will be there still. Come on, write these two equations there. Then what will be the value of maximum velocity? It is m1g by k into root of k by m2. Now come on, take this k into this one. You can write directly m1g root k by, that is root of k by k square m2. Now you can cut this k over here. Km2 will now be the left over here. So what will be the value now? m1g by root of m2k. Wherever this option that has been given over there, you look at that one. That is option 1 if you look at now. m1g in the numerator and m2k under root is in the denominator. So this is going to be the corresponding equation for the question number 17 as such. Look at the next problem, that is problem number 18. The time period of a simple pendulum is t. When the length is increased by 10 centimeter, its period is t1. When the length is decreased by 10 centimeter, its period is t2. Then in what way all the three time periods are going to be related? That is the question that is asked. In fact, t is equal to 2 pi root L by g. That of course is a known formula for us. T1 can now be written as 2 pi under root L plus 10 by g. And T2 now can be written as 2 pi under root L minus 10 by g as such. Now can't you just understand from this one, L is proportional to T square, please? If you square it upon both sides. Like that, L plus 10, is it not proportional to T1 square, please? Exactly like that, L minus 10, is it not proportional to T2 square, please? Now if you just look at L plus 10 plus L minus 10, 10 getting cancelled, you are getting T1 square plus T2 square is going to be 2L. So what is the relationship between these three? If you just look at, you will be finding that 2 times L is equal to T1 square plus T2 square. That in the sense, what is L is proportional to now? 2T square is equal to T1 square plus T2 square. Roughly also by look you can finalize the answer. There is no need for you to simplify the whole thing. It is now the correct option. 2T square is equal to T1 square plus T2 square. This is the relationship between T1, T2 and the value that is given as a T as such. That is question number 18 for us. Look at the next problem, please. That is question number 19. A spring of force constant K is cut into n equal parts. Already I just have given you the concept earlier. Whenever a spring having a force constant K is cut into n equal parts, that is the condition you people have to take up. When you talk about n equal parts, each part will have a spring constant which is n times the value of k. So this is a direct formula application itself which has been asked in one of the papers of EAMCET earlier. That is now nk, the fourth option that is correct here. And of course in one another EAMCET paper, he has given it is cut into 3 equal parts. What will be the value of k of each part was given in one more paper. That in the sense 3k will be the answer in such cases. That is the point you have to remember. Now look at the next number, that is problem number 20. The maximum velocity of a particle executing SHM is v. If its amplitude is doubled and the time period of oscillation is decreased to 1/3 of its original value, then the maximum velocity becomes how much? In fact, maximum velocity we have discussed several times earlier also. Maximum velocity, generally we write it as a omega. This now can be written as A times 2 pi by capital T. That is the concept. Now let us take maximum velocity for in the first case as V1, in the second case as V2. Then can't I just write A1 by A2 into T2 by T1? I can write directly this way, being 2 pi being constant over there. Now what are the values given, you see? If its amplitude is doubled, that means you can write amplitude 1 as it is and amplitude 2, you write it as 2A1 into. What about the time period? Time period decreased to 1/3 of its original value. If I take T1 as it is, T2 will now be how much? T1 by 3. Now T1 gets cancelled, A1 gets cancelled, you ultimately are left with 1 by 6 is equal to V1 by V2. But what is V2 the question? It is now 6V1. But we know very well in the problem given, the original velocity is given as V. So what will be the corresponding option now? 6V must now be the corresponding answer. That of course is tallied with the second option in this particular question number 20 as such. So this is the formula. Suppose if they ask you by any chance, what about maximum acceleration? Then of course we people is to write A omega square, that is maximum acceleration for this particular particle, whichever is in SHM, that is the concept. Now look at the next number please, that is question number 21. What is this concept? An ideal spring having force constant K is hung from the ceiling and a block of mass M is attached to its lower end. The mass is released when the spring is unstretched. Usually what happens is, when you just attach some weight at the end of a spring like this, and if you leave this one to its fate, then certainly it will elongate the spring now. But what is the condition he is mentioning, you see there? In this particular case, the condition is this: you have attached the body, but you have not allowed that one to elongate the spring. You are holding the body. The moment you all of a sudden release, all of a sudden release means what? That jumps just comes down. To what distance it goes? Twice the value, K becomes half. So what will be the corresponding maximum extension? Maximum extension X is equal to mg by K formula. In this particular case, the value of G will be twice G. Therefore, what will be the value over here? 2 mg by K will now be the corresponding option for us. In fact, by look you can tell this answer, no calculation that is needed. That is 21st question, that's going to be having the second option as such. That is the point. Now look at the next number please. That is, 2 light springs have time periods of 3 seconds and 4 seconds with the same load. When the springs are connected in series and the same load is attached to the system, then the time period of the system would be. In fact, you can directly identify this answer also. Actually, we have discussed T square, T1 square plus T2 square under root directly. Even if you write it also, you will be getting the corresponding answer. That means one is 3 seconds, one is 4 seconds. Then what will be the effective time period over here in this case please? It will be 5 seconds. One should understand one point here. T in series, suppose if they ask you, that is when 2 springs are connected in series by any chance. Springs are connected in series means what is the value of taking the K effective value? That is going to be K1 K2 by K1 plus K2. Likewise, when connected in parallel, what will be the effective value of K? It now should be taken as K1 plus K2, like we people used to take up. Even these two formulae also are important for you people to check rather to remember. But in this particular case, no further calculations are needed. Directly you can take up what is the corresponding answer there. That is of course 5 seconds. But one thing one has to remember, as far as simple harmonic motion chapter that is concerned, one question surely we can expect at EAMCET level. That's one. And there are certain areas of wave motion chapter in second year also, which has got some links with this particular chapter, simple harmonic motion. So by all means, remembering this chapter may fetch you one question surely and 2 occasionally. That in the sense 2 questions sometimes they may give. If such is the case, automatically one can score both the answers over there, both the marks they can score. That is actually the idea behind learning simple harmonic motion thoroughly. So I hope all of you might have got the correct idea about simple harmonic motion, and you all might have followed what are the concepts we have dealt with and what are the problems we people have taken up here, right? Thereby, this is actually the concept of simple harmonic motion. In the next class, of course, we people are taking up the concept of elasticity, where from also one question is expected at EAMCET level. That is actually the concept. If you look at that one, elasticity is the one which we people are taking up the next time. Till then,